Membrane filtration. Membrane filtration is a means of testing the quality of water. Water is filtered through a membrane having pore sizes smaller than the size of a bacterium. As water is filtered, bacteria are collected on the surface of the membrane. The bacteria can then be incubated to produce visible colonies suitable for analysis. Thermotolerant fecal coliformes are indicator bacteria which can form colonies at 44 degrees centigrade, and these are the colonies that provide evidence of fecal contamination of water. The analysis of colonies of fecal indicator bacteria that survive an incubation period indicates that fecal matter is likely to be present in a water sample. Fecal matter is an indicator of how many diseases that are transmitted by the fecal-oral route. So if fecal organisms are found, we can assume that disease-causing organisms, commonly called pathogens, are also present. So this microbiological process is about producing samples of bacteria for analysis, not samples of clean water. In order to prepare samples for analysis in the field, a portable field testing kit is used, which come in a variety of configurations as shown in these examples. The kits contain all the necessary components to produce samples of bacteria in the field and come with their own instruction manuals. The instruction manuals provide detailed instructions, so this film prevents an overview of the process. Always refer to the manual provided by the manufacturer of the field testing kit in use. To grow bacteria, you will need a supply of food. If you are to prepare your own, pour the membrane lauryl sulfate broth into a media measuring device followed by clean hot water. Use the amounts indicated in the instruction manual for your kit, as these can vary. Shake the media measuring device to ensure that all the powder is dissolved. As it does so, you will notice that the liquid turns red. Sterilization of the equipment. All utensils used in the process need to be sterilized to prevent contamination from bacteria external to the process. So sterilize the petri dishes and the filtration unit. Sterilize the filtration unit first, then, as it cools, prepare the petri dishes. To sterilize the filtration unit, squirt a small amount of methanol into the bottom reservoir and ignite it. When alight, turn the filter unit upside down over the reservoir. Methanol is used because formaldehyde gas is released when burned without oxygen. Formaldehyde gas acts as a strong disinfectant to sterilize the top section of the filter. In this demonstration, we are using aluminium petri dishes, which can be sterilized in the same way. At least 2 petri dishes should be prepared per sample so that you can cross-check the results. Once ignited and the methanol is burning well, place the lid over the bottom of a petri dish. Note that it is not the heat that sterilizes the filter unit or the petri dish, although that does contribute to sterilization. It is the production of the formaldehyde gas that ensures the items are adequately sterilized. As soon as a petri dish has cooled, uncover it and dispense an absorbent pad inside it to absorb the membrane lauryl sulfate broth, which is the medium that encourages the bacteria to form colonies. Using a sterile syringe, dispense the membrane lauryl sulfate broth onto the pad, covering it so that it is well soaked. It is important to avoid touching the absorbent pad or the inside of the petri dish, as this could introduce other bacteria accidentally. Note that the lid of the dish is not put on upside down, but the right way up, so that bacteria from the atmosphere cannot be trapped inside the lid. It is not completely closed, however, to prevent adhesion of the medium to the lid. When the filtration unit has cooled down, it will be ready to filter. Release the upper section of the unit filter so that it is just resting in place. Sterilised forceps are needed to manoeuvre the absorbent pad into place. If this is done manually without sterile forceps, bacteria on your hand will contaminate the pad. Ethanol is used to sterilise the forceps. Leave the forceps in the ethanol until required. Igniting the ethanol on the surface of the forceps sterilises the forceps. This should be done every time they are used. Shaking the forceps will cool them down ready for use. Collecting the water sample. Refer to the separate film about water sampling to find out how best to collect samples from a stream, a hand pump and water containers, which may also hold contaminated water. Filtration. Now everything is prepared and you have collected a sample of water, you can start the filtration process. Filters come in sterilised sealed packs, and each one has to be removed carefully, so that other bacteria are not introduced into the filtering environment accidentally. Place the membrane filter into the filter unit with the grid on top. Shaking the water sample will make sure that the bacteria are evenly distributed, as they tend to settle at the bottom of standing water. Next, pour the water sample carefully into the filtration until the 100 milliliter mark is reached, or to the depth recommended by the manufacturer of your test kit. By attaching the hand pump, air is evacuated to produce a partial vacuum, so that the water starts to filter into the base unit. When all the water appears to have been filtered, the unit should be shaken well to ensure that any residual water also passes through. As the water sample is poured through the filter, the bacteria are retained on the membrane along with any suspended solids. When you are sure that all the water has been filtered, release the top section of the unit, sterilise the forceps again and shake them to cool them down. Using the forceps, carefully remove the membrane filter, then roll it gently onto the absorbent pad in a sterilised petri dish and replace the petri dish lid. Rolling the membrane filter gently ensures that air bubbles do not get trapped underneath it. Growing the bacteria. Now label the petri dish and add your initials. Provide details to identify the source of water and the date of collection. Then leave it at room temperature for up to 4 hours, so that the bacteria have time to recover from the stress of the filtration process before incubation. The incubation unit provided in most testing kits will hold up to 15 petri dishes, so several samples can be tested at the same time. Follow the instructions given in the incubation guide to operate the incubator. After 14 hours in the incubator at a temperature of 44 degrees centigrade, the samples can be inspected. If thermotolerant coliformes are present, they will have formed into yellow colonies. Pink colonies indicate that the water was contaminated by other coliformes. It is usually possible to count the number of colonies of bacteria that have survived filtration and incubation, as each colony resembles a droplet of water. If a petri dish is filled with colonies too many to count, the number of colonies should be recorded as TNTC, meaning too numerous to count. In this situation, it is possible to dilute your sample using water that is free from bacteria to obtain a more manageable number of colonies. The water that was collected in the reservoir can be used to dilute water samples if required, as it has been filtered and is free from bacteria. When dilution is necessary, typically 10 milliliters of a water sample could be mixed with 90 milliliters of water containing no bacteria to produce a 1 to 10 dilution, or 1 milliliter of a water sample could be mixed with 99 milliliters of water containing no bacteria to produce a 1 to 100 dilution. The numbers of bacterial colonies on the petri dishes for these dilutions should then be multiplied by 10 and 100 respectively, to give the number of bacteria present in an undiluted 100 milliliter sample of water. Calculations taking into account any dilution can then be made to give a rudimentary indication of the level of contamination. For detailed analysis, the sample should be passed to a trained microbiologist.